With new technology being created daily, people wonder, what will the future be like? Well, if you haven't already noticed, we are here. We are in a time where technologies such as touchscreens, virtual reality, and intelligent personal assistants are becoming the norm. We are constantly discovering new technology and new ways of improving the old. Among these emerging technologies is one that I feel is making the largest impact across the most fields, and that is 3D printing. The technology has been around for a while, but we are constantly improving and finding new uses for it. I would like to tell you a little bit about how it works and the various fields we are using this technology in. Okay, so let's start with an easy question. What is 3D printing? According to 3DPrinting.com, 3D printing, or additive manufacturing, is a process of making three-dimensional solid objects from a digital file. You might say, that sounds like a simple definition for what seems like an impossible task. Let me go into a little bit more detail so that you get a better understanding of how this works. 3D printed objects are created using an additive process. In an additive process, an object is created by laying down successive layers of material until the object is created. Each of these layers can be seen as a thinly sliced horizontal cross-section of the eventual object. These simple, complex, and even functional objects can be made using less material than traditional manufacturing methods and take less time. I'd like to go into detail yet again and show you the tech side of things, as well as the different types of 3D printing, how they work, and what they are used for. Alright, so now we know that 3D printing uses a computer file to print three-dimensional objects, layer by layer. But how does this 3D printer get the file? While there are various types of 3D printers out there, they all use either two ways of receiving the computer-aided design file, or CAD for short. One way is to create a digital 3D object from scratch using a 3D modeling software. There are paid and free versions of these softwares, some obviously better than others. Then you must divide your object into hundreds of thousands of horizontal pieces, which is called slicing. This is done with slicing software, or in some cases can be done in the 3D modeling application. The second way is by using a 3D scanner. 3D scanners use cameras or lasers to capture a 3D image of an object and convert it into a CAD file that can be sliced and 3D printed. Let's look at some of the different types of 3D printers and what they're being used for. There are over 8 different types of 3D printing technology, each using slightly different technology to accomplish a similar task. Since there are so many types of 3D printers, I'll give you an explanation of the top 3 3D printing technologies used as of January 2018. I will also show you how they are different, what they are used for, and show you a demonstration on how they work. The 3 most used 3D printing technologies are selective laser sintering, stereolithography and digital light processing, and the most used 3D printing technology being fused deposition modeling. Let's take a look at each of these in more detail. Selective laser sintering technology was released in the mid-80s by an inventor and teacher named Dr. Carl Deckard. The technology uses CO2 lasers to fuse particles together layer by layer until the object is complete. This 3D printing technology can utilize many materials such as powdered metals, white nylon powder, and even ceramics and glass. According to 3D Insider, here's how it works. The build platform, or bed, lowers incrementally with each successive laser scan. It's a process that repeats one layer at a time until it reaches the object's height. There is an unsintered support from other powders during the building process that surround and protect the model. This means the 3D objects don't need other support structures during the build. Someone will remove the unsintered powders manually after printing. This results in incredibly fast printing speeds with exact precision. Let's see how this looks up close.
Okay, this is our new laser sintering machine where we process our own material iGlide L3. And now I'm going to show you how this works. Here you see how laser sintering works. The plastic powder is melted by a laser. When this layer is finished, the bed moves down by 0.1 mm and the next layer of powder is spread out. And then the next layer is again melted by a laser, and that's how the parts are printed layer by layer. And now the print job is finished. 630 parts are printed. This print job took 11 hours, and now we are going to unpack the print job where we are separating the printed parts from the powder. Okay, here we are separating the parts from the powder, and the powder can be used again. Here we see the blasting machine where we remove every last bit of the powder on the part. Okay, now all 630 parts are cleaned and ready to ship for the customer. And that's how actually laser sintering works.
The next 3D printing technology I want to talk about is stereolithography and digital light processing. These are both fast prototyping processes that are popular for their fine details and exactness. SLA and DLP printers are usually used to create unique models, patterns, prototypes, and production parts for various industries including automotive, medical, aerospace, and entertainment. According to 3D Insider, this technology works by converting liquid photopolymers, a special type of plastic, into solid 3D object, one layer at a time. The plastic is first heated to turn into a semi-liquid form, then it hardens on contact. In SLA, the printer constructs each of these layers using an ultraviolet laser directed by X and Y scanning mirrors. Just before each print cycle, a recoater blade moves across the surface to ensure each thin layer of resin spreads evenly across the object. The print cycle continues in this way, building 3D objects from the bottom up. DLP technology is very similar, only it uses a different light source. DLP uses a more traditional light source, usually arc lamps. This results in faster printing speeds because it exposes entire layers at once. With SLA printing, a laser has to draw out each of these layers, and this takes time. After that, the object goes through a post-curing process where it is given a chemical bath to remove any excess resin, then placed in an ultraviolet oven. Check out this video for a short demo.
So a bunch of scientists from a company called Carbon 3D just introduced a totally new kind of 3D printing. They were actually inspired to make it from the movie Terminator 2. Conventional 3D printing involves a printing head that passes over and over across a platform, depositing a thin layer of material each time. And this 3D printing forms an object continuously out of a liquid resin. So what's happening here is you have a bath of liquid resin that solidifies when light hits it. So the platform dips into this resin, and as it rises up, you have a projector underneath the resin pool that's projecting a series of cross-sectional images that are in the exact shape of the object you want to make. So as the platform slowly moves upwards, the projector moves through the different images, the different cross-sections, and that causes the object to form in the shape you want. Wherever there's ultraviolet light hitting it, that's where the plastic solidifies. So this could be a big deal because it's a lot faster than conventional 3D printers. It works in minutes instead of hours. Right now, 3D printing is still kind of a niche industry. People use it to make models or prototypes, but if this new 3D printer can be perfected, it could be possible for it to be used to make mass-produced goods.
The last 3D printing technology I would like to show you is fused deposition modeling technology, or FDM. This 3D printing process was developed in the 1980s by Scott Crump and is still one of the most used methods of 3D printing. Unlike SLA and DLP printers, FDM printers use a production-grade thermoplastic material to print its objects. According to 3D Insider, this method creates very strong objects and is popular for producing functional prototypes, concept models, and manufacturing aids. It does this simply by heating and then extruding the thermoplastic filament through a nozzle and onto a base. The time it takes to do this is based on the complexity of the object. After the object is printed, there is some light sanding required to smooth and finish the product. One company that's known to use FDM printers is BMW. Let's look at how this works. The additive process of 3D printing continues to change the way we create things today. The technology is saving time and materials for various companies including Hasbro, Hershey's, Nike, and even Ford. With 3D printing technology constantly changing and improving, it's only a matter of time before more companies look at this technology as a way of meeting their production needs.